Hey guys, welcome back. Today we're taking a look at position versus time graphs, and you're going to do a simulation with some robots, but I wanted to pull it up and do it and kind of explain a few things on the graphs to you because I know motion graphs can be a little bit confusing. So this is going to be a text box assignment, so basically you're going to open this simulation and then you're going to answer these 3 questions, okay? Now, when I was playing around with this, sometimes there was some difficulty opening this particular simulation, and I know that you guys have school-issued Chromebooks, so I'm afraid that it might not work or there might be some issues. So I'm going to make the video, and that way you can watch it and play through it, so that if for some reason this particular simulation robot thing doesn't work for you, you'll be able to watch this video and still use it to answer the questions, okay? So when you launch it, it basically has this little background information. It tells you that the little robots are racing to the elevator. Okay, so these robots are trying to race each other as they make their way to the elevator. And on the next slide, we're going to see some position time graphs that will show us their position and basically graph it for us. So I'm going to go ahead and click on this next button. That's the only thing we have to do. So here we have our robots, and there's a little play button, and it tells us their running profile. So they're both going to start off as aggressive, and then I'm going to show you how it can change, or how these graphs will change based on their running style. But basically you have how they're running to the elevator. They're going to start here and move towards the elevator, and as we click play, we're going to see what happens to their velocity versus time. Remember that in a velocity versus time graph, the slope is the acceleration. And then in our position versus time graph, remember our slope is going to be the velocity, right? So the slope over here is acceleration. The slope over here is our velocity. Okay, so let's see what happens when we click play and these 2 robots race to the elevator. And they made it. Okay, so they both had an aggressive running style, so they both have the exact same charts here. Okay, so let's take a look at what happened to their velocity versus time. So as they started out, they started accelerating, because remember, in a velocity versus time graph, we have the slope is the acceleration. Okay, so a positive slope is going to indicate an acceleration. A straight line is going to show us that they were moving at a constant speed, so there was no acceleration. A negative slope indicates a deceleration, and then here they came to a stop at the elevator. So what happened in this graph is telling us the robots accelerated as they started. As they picked up that speed, they decided they were going at a good speed and decided to cruise. Then as they approached the elevator, they decreased so they could stop right at the elevator. Okay, now our position versus time graph, remember that our slope is our velocity. Our position versus time graph, as we see, they were only moving in one direction, right? So they went from the left-hand side of the room towards the elevator. So what we're seeing is that this velocity is indicating that they're moving towards the elevator, which is in one direction, and then they reach it, which is at 15 meters. Okay, so this is just showing their position over time as they make it to the elevator. Okay, so their velocity is constant. They make it to the elevator, which is at the position of 15 meters. Okay, so now let's take a look and see. I'm going to leave Ruthie at the aggressive, so she's going to have the exact same chart. But let's see what happens if we change Erwin's running style. So let's see what happens if he decides to hustle, and let's replay it. Okay. All right. So when Erwin hustles, he has a greater acceleration, okay, because he's got a steeper slope, but he still comes to that place where he's cruising, right? So there's no acceleration here. Then he decelerates and comes to a stop. Okay, so it basically looks very similar to Ruthie's, but because he accelerated very quickly and he's hustling, he gets to a greater velocity. Okay, now in terms of his position, he actually overshoots the elevator, okay, because the elevator distance is at 15 meters. And what this is showing us, because this is his position, he overshoots it and he goes past the elevator. So the green line is where the elevator is. So Ruthie's able to stop successfully, but because he had a greater acceleration, he had greater momentum, so that he actually went past the elevator. Okay. So now what happens if we change it to lazy? What if Erwin becomes lazy? Let's take a look. So Ruthie's definitely going to beat him to the elevator. And if he becomes lazy, same thing. He's got a slower acceleration because he's got a not as intense slope. He comes to a cruise, so there's no acceleration here. And he starts to slow down as he sees that Ruthie is going to make it to the elevator before him. In terms of his position now, because Ruthie already made it and he's being lazy, he decides he's not even going to try to make it to the elevator, and so he stops. So his position is going to be lower than the elevator position. Okay, so if he wanted to make it to 15 meters for the elevator, he didn't quite make it. He only made it to about 10, so it's going to be plotted below. Okay. So then last one, there's one more, which is a confused running profile. So let's see what happens to Erwin when he's confused. All right, so Erwin, he's confused. He wasn't quite sure of himself. So he has a major acceleration, then a deceleration, then an acceleration, and then he stops when he realizes that he has overshot the elevator. Same thing kind of when he was hustling. He didn't quite know how to control himself, right? So he was just confused. He kept accelerating and decelerating, and he wound up past the elevator again, okay? So again, the slope here, this like super intense slope, is showing a rapid acceleration followed by a rapid deceleration, because the slope on a velocity time graph will show you the acceleration. And again, the slope on a position time graph shows you the velocity. Now remember, velocity has direction. It is a vector quantity. So here in this particular example, the slope is always positive because these two robots are moving in one direction. They're going from left to right. But just know, like, if there's ever a scenario, let's say if he was confused and he turned around and he went back to the elevator, these slopes could start to decrease, okay? So you could have a negative slope on a position time graph, and that would just indicate that the object has turned around and moved back in the opposite direction from where it came, okay? So that's what that would mean, and I think that's one of the questions in your assignment today. Okay, so hopefully this explanation helped to show what's happening. Remember, velocity versus time, your slope is your acceleration. If it's a positive slope, it's acceleration. A negative slope, like here's deceleration. And then if it's a horizontal line, that means a constant velocity, so there's no acceleration. And then on your position versus time graph, you have the slope of these is the velocity. So the steeper the slope, the higher the speed. And then if it's a positive slope, that means they're going in one direction. And then if you see a negative slope, so if you were to see a line to come down this way, that would indicate that the object has turned around and moved in the opposite direction. Okay, I know these can be a little bit tricky, but hopefully this helped explain that a little bit better. And if you still have questions, definitely let me know.